Okay, let's do this. I have my Paddy Mankovi here, and today we want to do a quick session, like a fun dive into web development basics, right? And I know if you know Brian, you know that this is his field. He's an expert, and thanks Brian for accepting to show me this. And in the course of showing me, I also want to use this opportunity to put it out on my platform for anybody that is interested in venturing into this. Again, I keep saying you can be anything. And these are some of the resources that we put out here to encourage anyone that is interested in something like this, right? Where can you start? Sometimes you have people ask questions like, hey, I really want to do this, but where do I begin? So some of these fun deep dives again, it's just an example of if you're interested in becoming a web developer, how can you do it? How can you start? This will just set a pace for you to now dig deep, get your hands dirty if you really want to learn. Okay, and so Brian accepted to do this with me. And then I decided to say, okay, let's do it for the public. So thanks again, Brian. Thanks for putting in the time.
Yeah, thank you very much, Sister Vips. It's an honor to always share, and there's joy in letting people see the joy in certain things that they think are cake. So I'm really glad if those that are patient and they really want to learn, I would love to really share, and
Awesome.
now and in the future. Yeah.
Great stuff. Let's get into it, man.
Yeah. So I mean, so like I told you, you to you, it will be like sometimes as though you're the one teaching me because I'll be asking you, and so that we can evolve. So I would like us to start with the idea of like development,
Yep.
and then look at even start growing from there, what it means and how we experience it in daily lives and how we can
Mhm.
transform it. Yeah. So, I mean, what do you think? You wanted to be minister now. Remember, you were saying you want to be minister and the rest. So, I'm very certain that you wanted to be because of the developments you think you'll bring. So, what do you
Yep.
think about development?
I still want to be minister though. It's not in the past. I still want to be a minister in Cameroon someday. Yeah.
Yeah.
But again, when we talk if we're talking about development here in the sense of, so when I hear development, I'm thinking different things, maybe because of the exposure that I have had in the tech world. So when I hear development, two things are coming to my mind. I'm not only thinking about development when it comes to infrastructure and maybe country-wise and stuff. I'm also thinking of, hey, development in the sense of technology. And this has been quite a mind opener. Why? Because when you hear somebody says I'm a developer, most of the time you would think that it's only tech, but there are developers that are also infrastructure. Is that the right word? Even infrastructure is still tech, but when we talk
Yes.
of like different ways of develop. So developer does not only mean they sit and they write code, architecture and all of that. They still develop all of those things. Am I correct? I say that.
It looks like we have a network issue, but
No, you cannot
yeah,
hear me. I can hear you
I
well.
can hear you now. I can hear you now.
Okay.
My screen flashed for a bit. Yeah. So,
Okay.
so yeah, I mean, are you done? Or
Yes.
you,
No, I'm good. I'm good. That's what I think. When I think development, that's what I think. It's either
okay.
writing code in tech or being a developer when it comes to like country building, city building infrastructure or like physical
Yeah.
infrastructure.
I
Yeah.
mean, like Donald Trump is a developer, right? Like those that do real estate, you have real estate developers, right?
Yes.
They turn land, they take land and then develop it now, either to a shopping mall. In Douala, they just developed the China Mall, you see. So
Yeah.
and then there are also developers like carpenters, right? Like
Mm-hmm.
imagine, especially here in the States where most of the houses are wooden, you see that
Mm-hmm.
the people that really transform those carpenters, they actually have a lot to do. In Cameroon too, when you need a bed, like going to the university, so
Mm-hmm.
the process is you go describe what you want to the carpenter, and then
Yeah.
the carpenter makes it using his craft. So if you want
Yep.
a chair, and a simple chair. You get 4 legs, then the place you sit this chair itself, then backrest. You would have that design, make those pieces of wood, carve. If you notice that the joints they used to carve into it so that they can fit in the other one. Yeah, that's the craft.
Yep.
Yes. And yeah, if you want to build a house, same thing. So now, uh, let's just think that's development, the art of like transforming something into another thing, especially a solution, because those that are religious, like they say, we are is it viscerals of God or Allah, so we're here to develop the earth, right?
Mm-hmm.
So so once we've captured that as the essence of development, the transformation, then we can now look at the world where we're in. So we have several systems. We have tribes. Uh, you have your tribe, I have my tribe, and they have the juju houses. There are like three things that mainly put cultures like that. They're how they see the world, what they think reality is, that's a metaphysics, and what they think is information knowledge, that's epistemology, and then what they think is right, that's ethics. You see, so but in doing this, there's some order. That you have a hierarchy. There's the chief. They have their roles. They have
Yeah.
their functions. Yeah, and then you see it breaks down to families. You're a member of a family because of blood and other things. So there's membership. So these are all things that happen in the real world. You see, and that's how the world is structured. So then even in terms of professions, so we just spoke about carpenters, they have their role and they perform things, and that's how they transform daily events into more events. And when I say events, when we're talking about development, we can be abstract in the sense that an event can even be a cup. Because when I say events, is someone going to send a party. You see what I mean?
Yeah, not
Because everything is
directly
energy.
happening.
Mhm.
Mm-hmm.
Yeah, everything is energy that is vibrating at different frequencies, and that's what make us see how they are. So that means that
Mm-hmm.
it's a vibration, it's an event that is happening when you see that cup. So I can call a
Yep.
cup an event. You see, so when you start thinking abstractly like that, then we get to a point where in this society is not just do we have people and functions and ways to interact, but we start having systems. So we mentioned builders, we mentioned carpenters. If you look through history, energy is very important. So people have always tried to look for a way to use more energy. So slavery, you take a bunch of people and make them work, build things, and then later maybe they'll use animals to plow farms, and then when they develop mechanics, you see they will start having pulleys, and now we have electronics, and we have even computers. So I'm just showing you some progression.
That
So
has
we're at
happened.
the point, yeah. So now when you see societies, people, things happening, and then we start having the use of energy, we want something that will do another thing really fast so that we can, minimize effort, maximize output. So that's why we even
Mm-hmm.
use computers. Yeah. So now as a developer, your main job is to look at the world and computerize things the same way that Trump or some developer is seeing a piece of land. He doesn't see the way you are seeing it. And carpenter, they look tree. It is seen as
Mm-hmm.
chair. You
Yep.
see what carpenter, they look tree. It is seen as a tree, correct? So,
Yep.
yeah. So as a developer, is to have that sixth sense where we are rebuilding solutions, but in the computer space.
Mhm.
So yeah. So, what do you think about that?
Yeah, I think it's an interesting way to put this, right? It's an interesting way to explain how the whole development thing. I do like the idea of, hey, if a carpenter is looking at a tree, they're not
Mhm.
seeing that tree. As a layman, you look at that, you're seeing a log of wood or something, right?
Yeah,
But that
yeah,
carpenter, when they look at it, they're seeing what they can build out of that tree. In the example, we should just use a chair, right?
yes.
So again, and I love that you call it a sixth sense, because it just means that you're thinking beyond what you are seeing out there. Like, hey, how else can I represent this
Mhm.
physical, this what you call an event. How else can I represent
Yes.
this event that is standing in front of me? So yeah, I think again that's a cool way to explain development.
Mashallah. Yeah.
Okay.
So now let's look at computers. Like, why do you think we have computers?
Why?
Any reason?
Computers. Why do we think we have computers? Why do we have computers? To
The same,
facilitate
the
work?
same reason. Yeah, the same reason we also had a times table. You know that
Mhm.
before they used to write on clay tablets, and then
Yep.
yes, and then only
And
chief quizzes, yeah, and then they
mhm.
abstracted it away. So human beings are always looking for like you said, that word facilitators. Yeah.
Yeah.
So and then since you have your background in linguistics, I would love to know how you see languages, right? Like if or let me put it this way, if somebody can, if there's a human being that cannot understand any language, can they be alive?
If they cannot
Let's say mentally,
understand
let's say mentally, any
any,
language. Yes, that's you just breathe, that's it. Because how you do not say stone as stone.
yeah, that's they get most of those things get learned, right?
Yes,
That's
but
how I look at it.
that aside, right? Like if there's I'm trying to paint the picture that languages are also lenses. You see,
Yeah,
there's
they see
languages allow
through.
you see the world. Yeah,
Mm-hmm.
that's because if I see stone, I don't know if it is in a stone that I know if you know in a stone. Like, you see what I mean? So
Yeah.
do you see? Yeah. So from a linguistic perspective, like, what relationship do you have with languages?
So generally with me, well, again, based on my experience, it's been a while since I've actually looked at the structure of language, and they say these things when you don't
Mhm.
use them, you forget them. It's almost
Yes,
10
right.
years since
Hmm.
I left the linguistics field. But then one thing that stays is that when I look at a language, when I think of a language, when if I want to learn a new language, or if I try to see how it is broken down. So
Okay.
one of the first things that happen in my brain, if I'm looking at, let's take a language I don't even understand, a language I don't know, and I'm learning a new language, right? One of the things that happens in my brain is that I segment that language. I'm looking at the structure, like, hey, what is the structure of this language? We all know that languages have different
Nice.
structures,
Yeah.
right? And I'm trying to understand the structure of the language. Again, when we are talking of languages, from the real sense of language, like English, French, Japanese, we are looking at different components, different parts of a language that you concatenate together, you bring together to make sentences, right? And these different parts, if you look at it, we are referring to maybe adjectives, nouns, verbs, all of those things. So these are the different parts that will now come together. But now, if I want to pick a specific language and look at it, I'm trying to understand, like, hey, in this specific language, what comes first? Is there like an adjective? Can this adjective come before the noun? Can the noun come after the verb? Like, again, just like an example, right? So it
Right.
when I look at languages with my linguistic knowledge, that is what I'm looking at. Again, I don't want to go deep into the phones, into the phonetics of
Okay.
things, but just
Yeah.
the both semantics and syntax of how languages are structured and how they are put together to make sense.
Mashallah. Thanks. Thanks for that deep dive. That actually helps me a lot. So another point of view about languages is the like you said, we have to facilitate things. So languages are very abstract facilitators. And I showed you one example that if you have a human being that cannot even you don't know a language, how do they so babes are they hungry? You
There
see
you
what
go.
I mean?
Yeah,
And things like
cannot
that. Look at
communicate.
babies that look at babies that only understand crying and the
Yep.
rest, right?
Mhm.
So now if we look at history again, you'd see that we had there's just so many languages. So the next thing I want to do is make you understand that almost everything is a language. You see, they mathematically we would say formal systems. So what you described about you having an alphabet and then having parts of speech, having the grammar that helps you know how to arrange the things. Yeah. So that's the formal system. So now, when you do a language, you are open to an infinite number of possibilities. So let's do a simple experiment. And yes, yeah, those who are to be developers, this is how you see the world. So when you're building systems, you have to be complete. You see, so that's why you have to go deep into things, because you even have to know the detail of how they're made from scratch. The same way you spell a word as a developer, you may even have to know how color is made in the computer. No one should shy away. If we go deep, it's just for your own understanding and about the fundamentals. So now, we spoke about progress, how, let's say, in Babylon, they used to write numbers on clay tablets. When we were growing up, we had it behind books. So if you remember the definition of that, like language as you specified as a formal system too, one of the easiest language we can look at is arithmetic. So it has an alphabet, 0 to 9, right? In terms of the grammar, you can put those numbers, you can spell with them, 2000 and 2000. Yes. So you see, arithmetic is a language, and then it has like basic operations that you can do on them, and that's what uses the grammar. So if you have subject verb agreement, and I say, I am going to school, me as a subject, and then going the verb, and then school the object, you see that there's a mapping to it, right? So that's how English is made. For arithmetic, when you say 2 plus 3, the action, the verb is the plus, and then the addend, that's what they call them, addend, and what yeah. So then we can start using those. You see, it becomes, sometimes things become cumbersome. If I want to add to 1 million times, just imagine you have say 2 plus 2 plus 2 plus 2 plus 2 1 million times. Better say 2 times 1 million, right? So you see that they facilitate that now with another operation called multiplication. So you as a developer, don't mind as these things are like that. You can actually learn a lot from arithmetic, just the way arithmetic is arranged and all. You can use the design. Yeah, you can use the design to, and this is how we build systems. It could be that, and as we get higher, you see there are cases where, let's say, you have a new Facebook user. So you can define an addition operation where when they register, you just add their record to the current user. So that's the addition. You see, so now if 1 million people register at the same time, you have to multiply that now. You see what I mean? So they have different servers, you take it, parallelize it, put it. So these things are simple, but you will see how it clicks.
Okay.
Yeah. Okay. So now, the same way that you see multiplication eases things, that's what languages themselves do. So instead of us, like I said, instead of adding to 1 million times, just multiply it. So when they make computers, right, they cannot determine everything the computer would do. And history can tell you this. If you look at Vandal machines, there are machines that say just Coke. All they know is Coke. You put in money, they give you a bottle of Coke. Yeah. So, but those are not general purpose computers. So if you want to do a general purpose computer where we can do calls, we can do movies and the rest, how do you make it general? So there's no way you can do that by predicting everything that can be done. There are some people that didn't know that phones will replace cameras. You see, so you can't determine how things will be used. So how do you solve that problem? Can you guess? That's the core to what we are doing here.
That's an interesting question. So again, if I understood you use the example of a vending machine that sells just Coke.
Yes.
And when you know that, hey, if you put a coin, you get Coke. But we're looking for an opportunity for a way that we don't want to limit it just to Coke. We want it to be opened up for a general purpose.
Like a computer.
Yes, okay, yeah. So in which case, what you put in, you want to be able, you're looking for the possibility to get anything out of it, but determine what you want to put in so if you define what you want to get out, then you have to put what you want, right? So in this case, if I want Sprite in the computer to give me Sprite, and I don't just put a coin, right? So there's going to be a double step. Instead of just putting the coins and the thing automatically shoots out codes, I can, before there's an extra step that needs to happen. There's a
Yes.
determinant factor, right? Like, okay,
Yes.
I'm putting this coin, but in addition to this coin, this is what I want. I don't know. I'm just thinking out loud.
Yeah, feel free. Yeah. Actually, I'm very glad because you're just evolving already. You're thinking out like a developer. We're trying to develop this concept. So, and then although I sense that you're trying to be sneaky to use like high level language, big talk. So, but we can feed in some of the things, all the answers and what we have already talked about. So you need to develop a solution for the thing that you want, which that's what you're saying, a determining factor, right? And then now my real question actually was, yes, we have to develop a solution, but what's the best way to develop the solution? And we've already discussed about the solution.
Discuss
So
the
it's a
solution.
language. Just make the thing to be able to talk.
To speak different languages.
Yeah, even if it's one. Even if he knows one, we can look for a way for people to learn that, and then you see that you can translate. Let's say if you teach it now a language, that you can start instructing it that, okay, there is a place called store, and inside of that store we're keeping different types of drinks. There is Sprite, there is Coca-Cola, there is this, and then there is a place called the cashier. That's where money comes in. So when money comes through the cashier, and it's correct. If there's change, give change. If there's no change, that's the cashier's job. When the cashier tells you the store that, all right, dispense this type of drink, then you do it. So we said it in English. So even if that computer has its own language, I can say it in English, but there could be one pie in the village that is speaking the dialect, and he can tell me in his dialect. If I know it and I translate it to the computer, there could be a French person, there could be a whatever. We just need one language for that thing. You see what I mean? So you see the power of like linguistics and so languages are amazing. That's how you extend things without you knowing the future. Just give a language so you can use that language to speak, because we can always say tomorrow now. You see what I mean? So and then we will always say tomorrow, because like they say, today is the tomorrow we talked about yesterday. You see, so that means so that means that you, even if it's tomorrow something new comes up, you just teach that done man with this language. So and that's why you see computers start shining. Computers check Facebook when it started, check Google as we're evolved. They're just talking it. You just talk to the server, teach the server the new thing. So you see the power of languages. Yeah. So summarily now, before we dive into like the meaty stuff, so it's just to make you understand that the way the world functions is like, for those that are religious, God gave us the word to develop. And then the restructure in society, how we do things, how you go use the bus, the train, and the way those things happen, we always want to facilitate them. So we need problem solvers, and that's just life. Like you have carpenters, bricklayers, priests, structure. So then we have now developers. I mean, everyone's a developer, but we have this space now of computing where we can use it today to easily facilitate things. And it's already been built and engineered and given languages that we can talk to them. So one other thing that we can talk about is, how do you see a computer? When you look at your computer, your laptop, what do you see?
What do I see? I see, again, literally, I see letters, numbers, and a screen.
Okay. So I don't know if you watch anime.
Some symbols.
Okay, I don't know if you watch anime. Or
No,
even
I'm not
movies.
an
Like you
anime
used to see
fan.
movies, but you guys, there's some. Have you ever seen a movie that has like a robot or some alien?
Oh yeah, those some of those
Yeah, at
sci-fi
least you
kind
have
of
that
stuff.
image. Yes, you have that
Mm-hmm.
image in your head. So, uh,
With these many
the question,
zeros and something showing in the air with no screen. I'm like,
yes. And then sometimes you see like a robot that is like a man, like a human being, right? But
mm-hmm.
or ion or something like at the end of Terminator.
Yeah.
If you watch anime, you would see there's a lot of Transformers animes that you have these things. So, uh, what's stopping you from seeing the computer like that, like a robot
Mm,
that you can chat with it? Because normally that's what you do, but the only thing is that the way it has perception, right? Like for input, we
like,
human beings, we have our eyes, our ears,
yeah.
nostrils for perception, right? Then we have output, sweating, things like that.
Mm-hmm.
And uh the for the computer, input is like through the keyboard, the
Yep.
mouse,
Mm.
output is through the
On
screen,
screen.
printers. So it's like a human being now. So what's stopping one from
Mm.
thinking of it like a robot? Don't mind how it looks. Say like keyboard, yeah,
Just
mouse.
say, give it something. Tell it what it wants, and it's going to react
Exactly.
to that.
Yes. So now the core of development is being able to learn the dialects of like the computer and then uh teach it the solution to a problem. That's
Yep.
it. So it's like a robot that is standing in front of you and you can talk to it in its language that do this, do that, do this, and then do this. And it says, your wish is my command. You see, and then it does it. You see, so yeah, so with that background, that's the highest summary of development.
Development.
Mhm.
Yeah,
So what
I
do you
think that makes sense.
So you tell me now what can be done then with the computer? We can look at what apart. We have. I know now we're using something that was built with the computer, but let's talk about that
Mm-hmm.
space. You two are in that space already, so like tell me a little bit about your experience, and from this discussion, how do you see it fit into what you're doing, what you'll be doing, and things like that?
So again, yes, I'm into that space in the sense that we set these things up, right? We configure these computers to work according to the way people want them to do the things that people want the computers to do for them, or the
Yes.
systems, whichever way we choose to call it. But yeah, I'll look at it to be, and I know I was telling you again when we chatted a little, I told you about when I did my first that I could write something and see it on a different screen and it comes and it tells me like hello world, right? If
Mhm.
anybody has ever been interested in development, I bet that we've all written a little, we have all succeeded in doing hello world, which is
Oh,
the
yeah.
most is the most basic um, development skill or development class when people teach development.
Yeah.
So, what's your question again? I don't think I
So
remember,
my
so
question
I
is
don't just
from what we
rant.
have discussed. Yeah, no,
Mhm.
you're on track actually. My question is from what we've discussed, and how do you see it fit into like where you are? That's just to see how what we've discussed, if how practical it is, right? If it summarizes a fraction of how things are, how do you see it fit? So imagine that you have
Yes.
learned web development until that all the nonsense we just talked about is why. How do you see it fit into like where you are?
Okay. Again, into where I am, I'm already having some level of exposure, right? So we are taking that into consideration too,
Mhm.
and um, it's being able the way this fits with me. One of the reasons why I will want to go deeper into this. I have written requirements for developers to give me results,
Yeah, right.
right?
Yeah, got
So,
it. Yeah.
which means I understand what I can get out of it. I just don't have that knowledge base to sit down and like I don't properly understand the language that my developers are speaking with their computers to give me the
Yeah.
outcome that they're sharing with me. And
Mhm.
so this fits into, in my case, more like, okay, this is me wanting to learn that language because I tell them in English, right? I tell them, hey, developer, I need you to make a button appear on this screen here, that if I click on it, it's going to take me to this other specific screen. And on this next screen, I want you to show me the map of this. I tell them that in English. They take it and they speak to the computer in whatever language you're speaking to the computer with, right? And that is that gap. That is the gap that if you ask someone like me, I could look at the language sometimes, and if I look deep enough based on my experience, I could see some of the things that they have. But I want to be able to understand that language. I want to be able to translate my English requirement that I'm giving them into that language that the computer will understand and give me the output that I desire.
Mashallah. Yeah. Thanks. I mean, that's a wonderful way to put it. It's also like how Pobia Fijeta say, Tangananji Sensei, be brief from Banga Pongo to Tole. He doesn't need to understand the laws of physics or how those people put it together, and economics or whatever, nutrition, how with the workers feed, but they build the bridge.
Yeah.
So, and you see that they develop it, right? Yeah. So yeah. So then the next thing that really takes us into a bit of a demo is now we have a computer. We know that we can communicate with it to extend it. That the best way to extend something is to use a language, because you can communicate present, past, and future with the language. So that's how you easily extend systems.
Yep.
So now let's review a little bit the computing space so that we see how now the development environments fit in. So normally we have we know a computer is a system. It has storage, like you can think of it like warehouse. So, and just to show you how these things fit in natural world, that's the most of these things, right? The way human beings are, there are some things that we go learn from animals. You see, like if we go learn how ants. You remember we studied. Some people used to joke that in Cameroon they taught us to draw cockroaches, flies. What's the importance of that? And I'm like, what the hell are you talking about? Like it teaches you organization. When you study taxonomy, you see how they do kingdom, phyla. That's how you. And when we discussed, remember we spoke about the earth, we spoke about tribes, we spoke about families. You see that's the order. So now the way there's nothing in the computer system that is coming from the computer system. It's coming from the outer world. They've looked at solutions. Like I said, we'll go look at animals. We'll go look at ants and understand that they have division of labor. Soldiers, workers, queen, and arrange so no. You see what I mean? So now the same with the computer. They look at the way the world is. The internet, the way the internet works, it actually works like a post office. You see what I mean? It took the idea of and the post office came before it now. Post office came before the internet.
Yep.
So yes, they just took the protocols of the post office and then computerized it and made it large scale, and that's how we have the internet now. So that's just to show that the things in the computer are just from around us. So as a developer, you need to be able to understand real life, like I said earlier, understand the basics. But with this layer I'll show you, I want to show you the layer so that you see that it's been facilitated until there are cases where you don't need to know that, but we have to build that up. So now on the idea of languages again, there are so many languages that you have learned, but you may not know the languages. You remember chemistry? We just spoke of arithmetic. You saw how arithmetic is a language.
Yeah.
So in chemistry, they taught us the first 20 elements. You just assume that that's the alphabet. Then you start learning how to spell with it, like calcium chloride, sodium carbonate. Then they start teaching you, saying when you add like sulfuric acid plus sodium, you have some water and carbon dioxide or sulfur dioxide or something like that. It's the same way when you read a novel or when you hear what I say, you're patching my sentences together to get the result. Yeah. So now, so with chemistry, you see there is another language too. So with the computer, all computers understand what they call binary binary. That's ones and zeros.
Ones and
So
zeros.
with those ones and zeros, they all have meanings. Like it could be that if you have 1111, it's add.
Yes.
So you can see that you have 11110111, but it takes the first four and says, oh, this encodes addition. Then I know that the next 1100, that's the next thing to add. So they've taught the computer that. So you can write to it in 1101111 if you know how to do it. But that's very cool. Right. So now remember when I said the computer needs to know only one language.
One language, yeah.
Yeah, so that's all the computer knows. 11101110. Yes, right. That's it. So now some wise people, the pioneers in computing, what they did is they created something called an assembler or assembly language. And when you have machine language, that's what it means. So it's able to take it's like mnemonic or abbreviations for those 111. So at is 1111. You could have jump is 1011. How do they call it? Store and things like that. So now that's all that language knows. Add, jump, move. So now it's like telling the computer, okay, move data from here, store here, take this from here, add here, read here, write. That's all it knows. Very simple. So then the assembler takes those and converts them back to the 111111. Easy. And then on top of that assembler, it's also cumbersome for you to be speaking few words, add, jump, move, location, that kind of stuff. So they build another language on top of it that will also have what they call an interpreter or a translator that will take that and convert it into whatever we can. So before we talk to them, I just put something so that man whet your appetite small. So for example, this is the browser. So
you have to share, you have to present again. You stop presenting.
Sorry. Yeah. I act like that man they didn't meeting. Either they forget to unmute.
No, they forget to say, can you see my screen?
Yeah, that kind of stuff there. Can you see?
Yeah, it's coming up.
Let me put it on the left. So that better. So this tool is.
Wait, give it a second.
Okay.
Yeah, give it a second.
Okay.
It's loading. There you go.
So we're talking about the layers of languages, and then the fact that we can have translators, interpreters that can interpret all those layers, and finally we'll have ones and zeros for the bare machine metal to run.
So again, to take you back a bit from going the other way around, we are looking at binary. You're looking at what did you call this again? You're looking at binary before interpreters. You mentioned something.
Assembly.
Okay, so the assemblers, right? So
think of it like abbreviations, mnemonics for the assembly. Yeah.
All right. Then now the interpreters that.
Then the higher, So as you're going higher, they call it higher level languages. As you're going lower, they call it lower level language towards the machine. So see the machine like a mountain or a pyramid of the stack. Yeah. So so and there's so many, there are thousands, if not millions, of languages. And there are language wars. Remember how I used to tell you that like all communities have issues?
Yep.
So languages, this one is saying my language is better. The other one is saying my language is better. So we always have these wars in computing. So but the languages are designed to according to taste, according to this a whole field. That's and it deals a lot with linguistics, like how to build languages. Yeah, that was actually one of my best things when I was in school. Like compiler. It's so beautiful. It shows you some deep things that you look at, so you say, if it's in the sweet, so then how God feel the feel away, no all thing. Yeah. So now you have these languages. So let's look at the browser now. So the browser is something that is like Explorer. Right? They'll call it browser. You go browse now. You go explore.
Yep.
The Apple one has been Safari. You see. So now, if you remember, we discussed about extensions. So they give you the browser, but how can you really make the browser do everything that can be done. So you see where the original problem is. Like how you had the thing selling just Coke. How
Coke.
would you make it? Yeah. So what is the browser even? Like if you ask yourself that question, it allows you to see documents. Let's just say documents to be abstract, right? Document can be a video or anything, right? So the browser allows you to do that. But imagine if the people making the browser have to make all the experiences you have. They never know before they even created Facebook, they created browsers. They didn't even know that there will be Facebook.
Yeah.
You see what I mean? So you see how that solution was spoken about at the start, where instead of predicting the future, just give a language so that when the future comes, you can just teach it. So
Teach
the
you the
browser,
language.
yeah. So the same thing happens with the browser. How do we know that YouTube is YouTube? Just use the language the browser understands and build the experience. How do you know that StreamYard is StreamYard? Before they built the browser, before decades ago. So you as a developer or anyone in this field will be learning how to like speak a language that the browser understands. You see, so JavaScript is that language for the browser. Let's start with you say they used to say hello world. So yeah, in the browser, let me make it bigger.
Yeah, that's what I was
So
gonna
I'm just
tell
doing
you. Though.
something simple. You say they always do hello world, right? So I'm
Yeah,
just
hello world is the most
yeah.
common.
So I'm telling the language. Why are you doing this? So that was an error. Oh, I see the error. So do that. So you see it prints hello world. And you see VM virtual machine 114.
Yep.
So the browser, there's a part that shows us pages and the rest. But now what happens is the browser is a machine. So the browser is so built like another abstract computer. And that's why you see things like VM for virtual machine.
Yeah.
So it has its own language, and then you can start using it to tell it what to do. So we just told it to print the string hello world, right? And it printed it here, but we're doing it in the console. So this
Yeah.
may have been some instruction that show a login form or show a button, and we'll get to that part. So and then in the like what said, it's the way the world works, that events, things that happen. So but we as humans, we usually classify things into like two spaces. There's things that are tangible that we can touch, and deal with things that are intangible, like processes, like
Yep.
time, color. I say, you don't ever see blue?
See
Do you
the
think
color,
they've ever seen blue? Yeah.
the color blue.
Yes.
Huh? See in the
Think
sky.
about it. Think about it.
See the color blue. I've seen the color. I see it on your
No,
screen.
nobody has ever seen blue.
So why? So that's why I need you to explain. What do you mean by that?
We've only seen things that are like
Things
blue.
that are blue.
Not that are
Oh,
blue. They are becoming blue, so they are not really are blue. So blue is like an abstraction. It's an idea, right? And that's why you have a spectrum. So you'd have like sky blue, light
different
blue, and
shades.
things. Yeah. So if you notice, there's no blue anywhere. You just have things that are in terms of
A
color, they have
different
that
blue
property that they're subscribing to blue.
to blue.
And yes, and metaphysically, they will say it's subscribing to blueness. Or they'll say a chair, you've never seen a chair. All the chairs you've seen are just things that are subscribing to chairness. So I'm just saying this because you have to understand that like we have abstractions and we have processes, things becoming. So the world, we have tangible and intangible. So in terms of the computer space, tangible things would be like data, like your username.
Yep.
For example, I can create something. So we always used to have stores, right? The idea of like data and stores. Remember when I spoke about the society, I said not just about people acting, but we have the way we do things, and we have types of data. You see, you have different professions, you have like different things we do at different places. You even when you're putting you in our houses, we'll probably have a container for water, have a container for oil, container. You see, so we always like structure things. So in the computer too, and at a certain point, we have different kinds of storage. Case in point, in your kitchen, you have like a cabinet, right, where you put perhaps containers,
Different things. Yeah.
Maggi over here, Bob over there, Ngakanga
Mm-hmm.
insert someone.
Mm-hmm.
And then when you start getting a carton Maggi, then you probably put it in the basement. And
Yeah.
then if your Maggi over plenty, you usually rent some storage. If your Maggi really plenty, though, you usually get a kind of
warehouse. Mm-hmm.
Exactly. So the same in the computer, right? So we can always just store things. You see, I just stored this thing called Monkey D. Luffy. This is something. It's string. It's one of my anime characters. I stored it in a place called the location called username. So if I come here now and just do username, oh sorry, I should have done username. And you see, it gives Monkey D. Luffy, and then the computer is very precise. So if you like grammar now,
Yep.
you know one of the hardest things with grammar is put comma. All that kind of right? Is that calculator put comma over here, all over there.
Yeah, yep. Well, it makes sense. It changes sense. It changes those. It could change the whole meaning of the sentence.
Yes. So in the computer too, it's very precise. So if you make a mistake, so now we had the reference error. So remember when I said you store this in a location, that location is like a reference, right? Like reference point. So we stored it here, and I did user. It doesn't yet know what user is. So that's why it says reference error. User is not defined. So the reason for these errors is so that to help now debugging, you do that all the time, right? Yeah. So so this is just an example like in the browser, but the reason this happens is because the browser has an interpreter for this language. You see, so now the interpreter will receive that language. We just typed one line, but when Facebook is telling the browser to paint the Facebook page, is giving it the folders. It does say Facebook, did you move into the browser? You're packed in there's a cartoon that's sent up with the browser. So you use this to paint that experience. So as a developer, that it would be that cartoon of instructions. So I mean, so this is the intro before we start coding. What do you think about all of this?
Yeah, again, I'm already interested. Again, this first part of it is something I'm already interested in seeing more, right? Because I'm already interested in seeing more of this.
Yeah, nice. So that's the interpreter part. So you see, again, it's just a language, and then there is an interpreter in that language that receives what you tell it, and then it renders. So now, again, when developing things, you want to put structure. So it's easy, just like we have division of labor and the rest. It's good to always divide things. So for building web applications, they have 3 main languages that they use. So again, division of labor. There's HTML. So HTML stands for Hypertext Markup Language, and we'll do a bit of that today. And then CSS stands for Cascading Style Sheets and style. And then we have JavaScript. So JavaScript stands for JavaScript. And then those 3 things do 3 different things. Sometimes it can do the job of the other, but especially JavaScript, you can tell CSS what to do. Yeah. So HTML, talking about division of labor, its job is to give structure. So we want to create web pages. So the scientists are like, how can we do it? So like we just discussed, you and I now. Why say the ISC now we just teach the browser some language where when you tell that language, Mangofi, you understand. Yeah. And then when the way they like make up, especially chap them, they say, oh, well, make that page. So how can we
need to beautify it?
Yeah, how if you arrange it so we need to know if for top for do you want the color go be so that I just that chapter we discovered that it. So they have cascading style sheets, so that does make up for the page. And then now we can start saying, okay, I have a page and it looks good, but that's just a page. I thought Ryan said somewhere that you can see the computer as a robot, right? How can I make it do things? So that's where JavaScript comes in. So JavaScript now brings life into these applications.
Action.
Yeah, you know, there's a joke that computer scientists always make that took clay, turned into man, and then the computer person took electricity and put it on sand and made the computer, because the silicon now, silicon is sand, right? Like the CPU. You see what I mean? So
Oh,
you don't
no,
get
I
it.
don't think I get it.
So
Mm-mm.
bad again. Only the five explain joke. So they always say God made man from dust, right?
Yes.
And then the computer scientists made a computer which is like a robot from sand by striking the man with current.
Oh.
No, not with silicon or sand. So they're using the silicon now, the chips that we're seeing on a computer, that's silicon and sand now. So they're using
Mm-hmm.
that to make those chips. Then with it, what slap the bed of electricity, they start doing it in and out. So that's a
Yes.
joke.
Oh,
That's a
okay.
joke they
Okay.
always say.
Okay. Yeah. Okay.
Mm. So
Really.
yeah. So okay, so now let's look at HTML. So at least so far you see how we've very briefly just gone from something that can do things with the power of structure, organization, understanding reality, transformation, development, languages, and we've come to the browser, right? So
Yep.
now we want to do some of those things. We want to use it to develop. So the one thing we should look at is that what kinds of things then can we build on the browser? What do you think the browser is, or web is?
There is a question what we can build, right?
You just mix it in and what we can build and on the web. What do they look like? What kinds of things are supported and stuff like that? Whatever you think.
It's a lot of things we can build on the web. We've seen we've
Yeah.
seen the web. It can show us a variety of things, ranging from even just information to um yeah, information, of course, first of all, right? We
Hmm.
can expose knowledge. We can bring in images, like show stuff,
Yeah. Right.
like hey, pictures of what can be seen. Um,
Uh-huh.
yeah, just
Okay.
summary with a term.
Okay. Got it. Yeah, so
Mm.
you can build everything. That's just to expand your mind, to show you that there's no limit. Another joke
Yep.
again in the computer space is that you're limited by your imagination. Is so when they only be
Yep.
a say if
Yep.
you imagine. See, you don't be imagine, leave
I've
alone.
read that
Yeah,
one.
exactly. So now so the browser speaks HTML. So the way the computer works to
Yep.
uh
That one I've heard.
everything is a file on the computer, even your mouse and your keyboard. The computer sees it like a file. So when you're typing on your
Mhm.
mouse, just know that your typing is a file that is being updated, and then the computer is interpreting the data, right? So now what is left is that the different programs in the computer react based on the
Interpreting it.
file
Yep.
type. Yeah. So when you're reading from the keyboard, you know that okay, it's a command or I'm here. When you're reading from the mouse, you know I should move that pointer. So one way now that with these languages we always do things is to give it a file type so that the interpreter in charge of that knows that it's a job for it. So that's why I'm creating this
Mm-hmm.
HTML file with .html. Normally people are used to files like uh, .txt, that's a text files. If you have
Can
.doc,
you are you able to blow it
so
up a
maybe
little bit if
okay,
you can? Yeah.
all right,
Okay. Mhm.
like that. Is it okay?
Yep. Yes. Yes. That's a lot better.
Let me make this other one small.
Mm-hmm.
So, we named this file index.html, and that's to let the interpreter or the browser to know that it's an HTML file. And I asked
Mm-hmm.
you what we can do with HTML or like on the web. You said pretty much anything. So the easiest thing we can do now is let's create like a web page that just displays some text. I can generate some random text here. Let me generate Lauren Ipsum. Voila. Did when needed. Their structure, how they do things. So look at HTML. So like I said, HTML stands for Hypertext Markup Language. So when they talk of markup, Today, you and I showed you another markup language, right? Markdown. You remember, like on your WhatsApp screen,
Oh,
what you're
yeah.
gonna use to make bold. Yeah, that's a language. It's called Markdown. It's
Mm-hmm.
so it is have the language. If you look, and you can do magic with those things if you understand it. So markup language is the way they are. You are playing tag with information. You know tag, like you play some funny
Mm-hmm.
game. And what is tagging?
Good.
Those that are so organized, you could have your cupboard or your dresser at home. You write so saying and make up the year.